How are you? Can you hear me?
Yes, I can hear you. Thank you.
Thank you so much for being here, and we are really honored to have you as a keynote speaker. So I'll ask the audience that if they will be having any question related to Celine's presentation or related to Nagaraj's presentation, they can ask in the chat and in the QA session. So, ladies and gentlemen, Celine Zhu is a lead data scientist from H&M Group, and with 8+ years of machine learning and AI experience in Nordic, Celine is passionate to leverage the advantages from both human and machine, and using ML AI to understand style and to transform fashion. So she will be sharing her thoughts on predicting future of data science and machine learning in fashion. So, Celine, thank you so much for being here.
Thank you.
Uh,
Should I wait 3 more minutes?
no, you can start your presentation.
Okay, sure. I will share my screen first.
Okay, sure.
So let me know whether or not you can see that.
Yeah, I can perfectly say it. Good luck. Stage is all yours.
Cool. Thank you. So thank you so much to having me here. And today my topic is when machine learning meets fashion. My name is Celine Xu. I'm a lead data scientist in H&M Group. I'm also a fashion lover. I have a big dream to bring fashion close to machine learning, to let machine learning understand how complex fashion will be, and to bring machine learning more close to fashion, to let the fashion understand where uh, machine learning can help fashion ways to create value. So in order to understand I guess everyone know that H&M as a fashion brand is established 1947. Until now, it have been 75 years. But as H&M Group, we have multiple brands under it, more than 12 brands, including COS, Actel, and the other story, and so on and so forth. The organization I sit in called Business Tech. During the past 2 years, we have 200% growth. And we have more than 150 machine learning engineer, plus data scientists and data engineer. We have more than 30 machine learning products already in production, and more than 6 of that scaled globally. So today I want to share some of my understanding and exploration about how to effectively apply the machine learning in fashion industry. This is the takeaway part one. First, do not use machine learning to forecast the fashion trends. It may not work. Beware of limitation of image recognition capability currently. Do not focus on matching individual item from street format to store format. And do not limit it, a customer to a single fashion style. Let me elaborate more. First, I want to elaborate my understanding about or my finding about the conflict between the essence from fashion and machine learning. Why I see fashion is not predictable. The essence, let's talk about the essence of fashion. So according to Wikipedia, fashion is form of self-expression and autonomy at a particular period and place in a specific context. It's including clothing, footwear, lifestyle, accessory, makeup, hairstyle, and even body posture. And fashion trends is a specific style or expression distribute over a population at a given period and the location. The point here is fashion is about change, is about subjective interpretation, and the product from fashion industry compared to other industry like grocery, music, food are more vague and hard to define, and even harder for classify in terms of style. Today, to simplify or narrow down the scope, we'll only focus on ready-to-wear garment sector in this presentation. Then, to understand the conflict, let's move on to the machine learning. What is the machine learning? Machine learning for me is just to build a statistic model based on sample data or historical data to make prediction or support decision making in future. Machine is good at learning something in common in history and calculate the probability of future happens That probability is about certainty and based on an assumption that history will happen again under a certain context, which means the machine learning really good at predict what will happen again in the history, in the sample data, but not actually the change. And also, all the learning is based on the sample data. It always have the bias in machine learning comes from the input of the sample data. Why I mention here is fashion. It have a lot of dimension of data, including the culture, the emotion, the story, but not everything can be standardized or convert in the statistic format. So it creates extra hard for machine learning to learn fashion. To make it simple, I want to repeat and compare the fashion and machine learning from conflict perspective. First, fashion is about change, innovation, uncertainty. Fashion designer find inspiration from specific instance from the multiple aspects of life, including culture, lifestyle, personal preference, or even a single accident. Those things are really hard for machine to turn into the statistic model. And it's really hard to identify and predict. However, machine learning is make prediction on the historical or sample data, which assume historical will happen again. If fashion is about change, is about uncertainty, then the machine learning is about certainty and understand that what will not change. Second, style or vague is about feeling subjective to individual at a certain time. However, in order to make a machine learning work, we need to make a machine learning model. To make a machine learning model, we always need to quantify concepts or business problem into a statistic model under a standardized rule and apply the same logic for prediction. And this vague of style description and feeling is really hard to quantify it into a machine learning model. Last, I would mention trends are defined by a small group of people. It's from Vogue, Ella, from a really luxury goods like runway show. However, the machine learning is really good at review the common rule from the big data, which is from mathematics, social media and mass market. So why, if we already know the trends is actually defined by a small group of people, why we look at mass market? And mass market may be just a follower. If those things not actually convincing you, then I would say if you still want to do the fashion forecasting, some question you should ask yourself before you actually do forecasting. For example, where does your data source come from to train the model? Whether or not it's from the mass market like social media, and who label the data, how do you label the data and who label the data? Whether or not it's labeled by the customer without any design expertise, or is actually labeled by actually engineer without any fashion understanding. The other one is, can you do anything after you know the forecasting, Why I'm saying that is, normally, statistically, for a trends from social media, it only lasts 3 to 5 months. However, I know most of the manufacturer have the supply planning cycle more than 6 months. So when you know those short-term 3 to 5 months trends, how you can actually affect your designer to redesign your product and put in production. Whether or not it's still effective. Last but not least, I would like try to challenge. Why not use human instead of machine to do the forecasting regarding fashion? The fashion forecasting already exists for more than 200 years by specialties, but not really from the machine perspective. And also currently we have more engagement from co-creation with customer. Instead of predict what trends the customer actually like, why not engage your customer, actually co-create what the combination of outfit they actually engage? In that way, you may get more engagement and more sales. So my point here is maybe it's good to let machine do what they're good at and let the people do what they're good at. Then what? Since we cannot actually use the machine learning to predict the fashion trends, what we can predict? Fashion is about self-value reflection, is about the society engagement. That is the long term. So why not use machine learning to classify which community the people belong to or want to belong to? That is why sometimes we use this clustering in machine learning, not able to beating the traditional marketing perspective use customers segment based on their understanding. The second one is, since machine learning is really good at summarize the common feature of a specific data set, so why not use machine learning to summarize the common feature of a time period and discover the trends will come back and when will come back? Instead, to predict the trends will always change, will always twist, will always be new. Last but not least, as I mentioned, it's always based on where you look at the data, at what time, and at what purpose. Maybe social media data is not good for helping designer to redesign the product, but it actually can help the company learn what term customer actually use for search the item they want. Next, I want to mention some limitation of image recognition in fashion. Because most of people have a little experience with image recognition and they assume machine recognize things as a human being. There are three big tasks for machine in the fashion industry. The first one is called color classification. The second one is object detection. It's used for tagging fashion feature of specific item. And then it's about objective point direction, because normally we need to understand whether or not an object is on the different direction. We need to rotate it to match in a certain position. So we need to have this object point direction. So first, let us try to understand how computers see an image. Pixel is the most smaller element present on the screen for lowest level for analyzing in computer vision. And a pixel is characterized by following attribute, actually two. One is the position on a grid, and the other is the measurement related to intensity of the light. It has a gray scale from 0 to 225. If we have more complex case, if we have a colorful picture, then we have three of this kind of metric together represent RGB value, which is red, green, and blue value individually. In general, we can see as a graph on the left side, we can use a metric 6 multiplied by 7 metric to actually represent it. If we talk about normal value, no matter whatever the algorithm in between, we call it feature extraction. We use either encoding or embedding and translate a specific 2D image into different metrics, and then we stretch that matrix in a long image vector representative. The long vector representative statistically is how the computer sees the image, not the identity. Then how does the machine learn the difference between the image? It's all about depend on how we define the distance between the image vector. And it's not universal distance. Here I show 6 common use distance to define the image: Euclid, cosine, Hamming, Manhattan, so on and so forth. My point here is instead of understand, not like human, understand image, which based on the historical understanding of their memory to be compensate and lack of the image to the whole picture. The machine identify an image only based on their statistical value, which based on the algorithm represent and the distance they define. So there is a ridiculous things here is on the right hand side, there are picture of muffin and dog. For human, even a small kid like 5 years old, you can easily identify which is dog, which are the blue muffin. But this is a big challenge for computer. Furthermore, when recognize an image, the resolution or the quality of image is critical for the machine. Why I'm saying that is if you use the same dress on the before the same background, but if you use different resolution of camera, then the machine will recognize two objects actually different. It's add another layer of difficulty for image recognition. Let's get more intuitive from fashion perspective why I mentioned this limitation of image recognition. The first example is here are three same dress with different saturation adjust. In machine's eyes, it will recognize three different dress. The second, the most common case, a product hang in front of the white wall, and that is a standardized product image, and also a product actually on a model or a fashion blogger. The machine will recognize it differently normally. And even for the same dress, because it's 3D, if we rotate the angle for shooting the picture, the machine will recognize it's different object because they have different line, different angle, different color at the same pixel. Then in more reality, even the same dress dressed by the different size, different people, we probably identify they are not the same. And also, if we want to tag this dress in different style, it actually in different style. And also, if even the same model have the same dress on herself, if she do different pose, the machine normally will recognize that as a different objective and object style. Why it matters? Because currently, what we try to do most of the image recognition is try to find out what actually the item in the social media and try to match it back to standardized product picture in the product catalog. But it normally doesn't work. And more interestingly, there are some dress you actually can wear in different way. So even human eye will recognize it in different size, style or object. And how can you let the machine know? More often, and I will stress more later, is the style is not really related to individual item. It actually related to the combination. The same white shirt, if you combine different trousers, accessory, bags, you actually can give different tag of style of it. And from machine perspective, they can't actually recognize them as the same object. So to make it more clear from fashion perspective, there are 5 categories. Fashion expert will classify their fashion product in. We call it fashion feature, which is color, textile, pattern, silhouette, and quality. And we can try to compare what reality is in today's world and what actually current most of the machine can tag output will be. First, let's talk about color. So in reality or in the normal fashion sense, we have more than 200 grade of color with names for designer for choose. However, from machine perspective, as I understand, like more than 5 application in the market, they can at most recognize 6 to 12 colors. Why it matters? Color represented by hue, saturation, and value dimension. Normally, statistically, it has hex value. But due to the quality of the picture and the classification algorithm difficulty, they can only symbolize it in a single category. And for human being, normally statistically, humans choose their clothes 60% more which they will give for the first glance of the color feeling. And this color can be the warm and cold due to their skin tone. So let's imagine if you want a sky blue skirt, and in the end, you find a blue skirt is actually in indigo. How do you feel? Or if you tend to buy a rosy dress for your daughter, and when you search red, it's turn out and ruby dress, how will you feel? Let's move on about textile. When we talk about textile, it's more about the fabric of the garment. In the market, normally we use commonly 80 to 90 euro use common use material, but only from image or surface, we as a human being, we can recognize 12 different material. But with touch, with sense, we can identify more. But from machine perspective, they can only recognize 4 to 6 type with limited accuracy. For example, it's really hard for machine to identify whether or not it's synthetic silk or that is silk. Let alone to tell whether or not this specific wool product has how much percentage of wool, only based on the surface. What I'm telling here is why we obsess with increase the image recognition's capability for the accuracy, whether or not we can find a combined way to find more realistic approach to let the machine learning help fashion. About pattern, the pattern maybe is the best performance section in image recognition. For example, they have the clear line, the size, and the angle. However, the problem is turned to be who label the pattern. For example, for designer, if a certain rows have a smaller size, have multiple repeated size in a single clothes, they will call it differently with a single rows on the single clothes. Not alone whether or not this rows appear as a decoration of the garment, or is that under the button of the garment, or it's actually print on garment. It's totally different. However, when we find the tagging of the different scenario, the machine normally always output rows dress. So whether or not it will help the designer or customer to find enough information about the product they want to do. More, it's about silhouette. It's also good for the clear line. However, the thing here is most of first, between each specific design style from one direction, they have kind of really small differentiation between it. For machine, it's really hard to classify that. And more worse, normally it's engineering people actually tag the image, which means they were not in the granular level, the designer or customer need to tag the image. In this 20 different skirt, normally in the image output, we'll only say it a short or midi or long skirt. At most have some like A shape or H shape. However, no machine can tell which one is A-line dress, which one is tulip dress, which one called pencil dress. And when you put bodycon dress, the machine cannot output the result you actually expected. Last, but actually the most in, important fact for pricing a product is clothing quality. Here, the quality is means the quality of fabric, sewing technique, the construction of proper lining, and how you actually do the bottom closing. For that one, even a human eye touch it, move it without specific knowledge, you can't actually tell which t-shirt actually deserves $500 or it's just $5. So from this perspective, the machine cannot tell anything. The point of this is image recognition have the limitation. If you want to match a specific item, they have really restrict requirement like same background, same size, full view, same angle, same camera, and same backlight. And even worse, we have the clothes in 3D. And normally how we define whether or not a clothes or dress is good. It's based on their movement with the body. Those things we can never ever from the machine image recognition. So is that smart to focus on improving the image recognition accuracy? And what else we should do? What kind of solution from HM Group is a data scientist, Jonas? He came out. We can actually find a positive anchor and a negative anchor to build a semantic layer to let the machine understand a specific item and to tell what the new product is more like or not more like that anchor. How we define this like or not like is not based on the fashion feature we tagged and identified from the picture, but actually only based on human behavior, which the searching industry, the search sequence for each visit for a specific time. This way, we actually avoid the accuracy trap in a certainty to understand the specific fashion feature of the clothes, but still can provide some insights for customer what they mostly like to buy or not like. It's like to teach an English speaking person how to respond correctly in Spanish in the letter without let him actually understand each sentence what that means. So I want to emphasize machine is not person. They understand image differently. And machine is not as smart as person. Next, I want to move on and to what's next. What we should focus on to improve machine learning in fashion industry. First, I want to say every consulting firm actually believe personalization recommendation will help company generate more value. And how normally we do the recommendation? We use historical records. We use point of sales, the buying basket, and we try to find out the scoring in the item, no matter is the popularity or is that similarity or affinity to the person, based on the style tag on single item. However, it's really not the case. As we mentioned, a single white shirt can have different style based on different combination. So why not we actually focus on understanding the style of the combination instead of the single item to give the suggestion to customer for more future impact. And also, normally we do the recommendation based on point of sales of the point of sales of the single basket. However, normally the things we buy together is not we can wear together. So why not use machine learning, actually try to identify different objects in the same picture and find out the relationship between the object relate to the style and do the recommendation about the combination instead of only understand what material, color, or shape of a single item. I think it will be more helpful for customer for their search and life. Last but not least, I would say for myself, I feel like the same person can have multiple style under different circumstances. And normally people want to try out new things is based on the style they don't really know. So why not you actually predict this person what is the most attractive style they have? Why not you actually on the other side, you support these people with no matter style they actually choose, but you can help them to look better. So as repeat, style is the way of customer express their self and the new identity the customer want to be. This is the stable part of the customer, not the fashion feature part. And the style reflect the value of the customer choose believing and the community customer want to be engaged in. That's why let the machine to actually predict the community belonging of a certain customer is far more powerful to actually identify which style this customer would love to have. HM Group position ourselves as personal styler, supporting and guiding our customer to find a suitable outfit, no matter what style they choose. We are not a style leader, but we try to make whatever style is affordable for our customer. So HM Group wants to become the first brand choice of fashion inspiration, creativity, and culture. Then the final takeaway is maybe it's not really effective to use machine learning to predict fashion. Instead, it's good to predict customer social belonging. And do not try to match a single item from street format to the shop format and identify their style. Instead, focus on identifying multiple objects in the same picture and mapping the relationship between the combination of the style. Last but not least, I would say customers have their own idea. Why not encourage customer have different style and just support them with professional guide, no matter what style they want to. Thank you. Any questions?
Hi, Celine. Thank you so much